The coordinate plane. You have previously learned how to plot points on the coordinate plane. For example, we have this plane. In the opposite figure, we have point A equal 2 and 1. We have point B equal 0 and 3. We have point C negative 2 and 2. We have point D negative 1 and negative 3. And the point E equal 3 and negative 2. And the last one, the point O, equal 0 and 0, which is the origin point. Remark, we have x-axis and y-axis, and we have 4 quadrants. The first quadrant, x positive and y positive. The second quadrant, x negative and y positive. In the third quadrant, we have x negative and y negative. And in the fourth quadrant, we have x positive and y negative. Example number 1. In the coordinate plane, plot the following points. We have point A, 3 and 2, 3 on x-axis, and 2 on y-axis. So this is the point A. Point B, negative 1 and 2. Point C, negative 3 on x-axis and 0 on y-axis. So the point C will be on x-axis. Okay? The point D, 1 in x-axis and 0 on y-axis. So the point D will be on x-axis. Then how can we calculate the area of the figure ABCD? We have ABCD is a parallelogram, and its area, the area of a parallelogram equal base length times the length of the corresponding height. Again, the area of a parallelogram equal base length times the length of the corresponding height. So we have in this parallelogram base length equal 1, 2, 3, 4. So we have base length equal 4. And we have the length of the corresponding height equal 2. So we have the area equal 4 times 2 equal 8 square units. Self-evaluation 1. From this figure, determine the coordinates of the vertices of the triangle ABC. Then calculate its area. We have the point A equal 1 and 3. So 1 in x-axis and 3 on y-axis. Point B equal negative 2 and negative 1. Point C equals 3 and negative 1. So if we match these points, we will have a triangle ABC. And the area of triangle equal half times base length times the length of corresponding height. And if we match these points, A, B, A and C, B and C, we will have a triangle ABC. And its area, the area of triangle equal half times base length times the length of the corresponding height. So we have the area of this triangle equal half times 5 times 4 equal 10 square units. In example number 2, if point A 4k plus 4 and negative A plus 3 lies on the y-axis, determine the quadrant in which point B, negative 2k and 4k plus 1 is located. First, the point A lies on y-axis, so we have negative k plus 3 equal 0. Again, point A equal 4k plus 4, so the x-coordinate is equal to 0. So we have 4k plus 4 equal 0. We can take this 4 another side with inverse sign. So we have 4k equal negative 4. How can we find k? We can divide both sides by 4. So we have 4k divided by 4 equal k. And negative 4 divided by 4 equal negative 1. So we have k equal negative 1. By substituting the value of k in the point B, we will have b equal negative 2k equal negative 2 times negative 1 equal 2. And 4k plus 1 equal 4 times negative 1 equal negative 4 plus 1. Negative 4 plus 1 equal negative 3. So we have the point B, 2 and negative 3. In point B, we have x positive and y negative. So B is located in fourth quadrant. Remark, the point x and 0 lies on the x-axis, and the point 0 and y lies on the y-axis. Again, the point x and 0, if y equals 0, so this point lies on the x-axis. And if x equals 0, so this point lies on y-axis. Now let's learn about projection of a point on the coordinate axis. What is the projection of a point? Projection of a point in a coordinate axis. To find the projection of a point, such a point A, 2, and 3, if we have point A equal 2 and 3, on each of the x-axis and y-axis, how can we find the projection? To find the projection on x-axis, if we have the point A, 2, and 0, to find the projection of this point, we will draw a perpendicular line from this point to x-axis. So we have this is a perpendicular line, and this line intersecting x-axis at the point A dash 2 and 0. Therefore, A dash 2 and 0 is the projection of the point A, 2, and 0. Okay, so again, to find the projection of any point to the x-axis, we will draw a perpendicular line from this point to the x-axis. And to find the projection of this point on the y-axis, we will draw a perpendicular line from this point to y-axis. Look at this point A, 2, and 3. To find the projection, we will draw a perpendicular line on y-axis. This is the perpendicular line, and this line intersecting the y-axis on this point A dash 0 and 3. Therefore, the point A dash 0 and 3 is the projection of the point A on y-axis. Okay. So to find the projection of point A on the y-axis, we will draw a perpendicular line from this point to y-axis. Remark, if a point lies on the x-axis, its projection on the x-axis is the point itself. لو البوينت دي هي already موجودة على الاكس axis، يبقى البروجكشن بتاعها هيكون نفس البوينت، هيكون البوينت itself. Okay. And if the point lies on y-axis, its projection on y-axis, it will be the point itself. Now let's learn about projection of a line segment on the coordinate axis. We learned about the projection of a point. Now let's learn about the projection of line segment. Okay. Projection of a line segment on x-axis. How can we determine the projection of the line segment on x-axis? To determine the projection of line segment on the either axis, find the projection of its endpoints on that axis.
تقدر تتابع كل دروسك على تطبيق مدرستنا بلس. مدرستنا، المستقبل يبدأ الآن.